Okay, so in our next example here, we have the integral of x squared sine x. So following the idea from before, it's a good idea to let u, stuff you're going to differentiate, involve your powers of x. And then we let dv be the other stuff. Okay, and then we can differentiate u and get du is 2x dx, and integrate, integral sine is negative cosine. Okay, and then we use the formula. This thing is going to be equal to uv, so uv, x squared cosine x, so I'll just write that as minus x squared cosine x, and then that's minus the integral of v du, so negative 2x cosine x dx. Unfortunately, we're not able to integrate this one either, because it also still has a product. So let me just do a little bit of simplifying first. X squared cosine x plus, I'll bring the 2 out because I don't really need to worry about that, x cosine x dx. So what I'm going to have now is I'm going to need to do a second integration by parts on this x cosine x part. Okay, so I just repeat my u du stuff again. So here I can let u be x, again powers of x are good choices, and dv be something that's easy to integrate. And so cosine x is easy to integrate. And then we differentiate du, we'll just call for a dx, so we know it's eventually going to get to an end. And integral cosine, remember, is actually positive sine. Okay, so we have this first part here, minus x squared cosine x, that's just going to carry around. And then it's plus 2. And then we use the integration by parts formula to work out the integral of x cosine x. We know it's uv, so plus x sine x, minus the integral of v du, minus the integral of sine x dx. All right, and then we simplify. All right, we simplify. So we're going to have negative x squared cosine x plus 2x sine x, and then integral sine is negative, so that's going to be plus the integral sine, which is cosine, and then that's also multiplied by the 2. So plus 2 cosine x, and then plus a constant. Okay. So the derivative of all that stuff, as we discovered, was x squared sine x. Now, to take this thing and differentiate it, you'd have a product rule here, right? And you'd have a product rule here, and what you would find is a whole bunch of other stuff. As you're doing it, would cancel out, leaving you only with x squared sine x. Okay. I actually did an example in my Calculus 1 class. We just did an example recently. I'll take you back and show it to you here, where we actually did, if I can find the right one, here it is. It's actually very similar to the problem we just had, except this stuff, when we differentiated it, actually was the w squared cosine w, so slightly different, but you can see it as that same kind of format as the one we have, just things are a little different because you're dealing with w squared cosine w now is the result. You can see when you expand it out, a whole bunch of stuff cancels out, leaving you with that. So this was just, they're not doing integrals, of course, of something like this. Right now they're just still learning derivatives. But it's just a neat example because it does kind of tie back to what we're now doing, which is figuring out what do I differentiate to get that. Okay, and that's what our integration by parts is actually doing, is letting us figure that out. Okay.